Alright, so welcome to the next video on limits. This one actually has some more math in it. This is going to be computing limits if you have a graph. So this is sort of one of the most friendly things you can do because you have a picture in front of you and the picture will help you figure out what the limit is. So before we get started, there's going to be 4 types of limits that we're going to do. The total way to approach this is going to be based on looking at the first 2, which give us the third, and then the fourth one is actually totally different. So the first one is the limit as x approaches a from the left of f of x. We call that the limit on the left. The next is the limit as x approaches a from the right of f of x, and that's the limit on the right. The next is the combination of the 2 previous ones, which is just the limit as x approaches a of f of x. We don't specify the left or the right because we really want to know what happens when we go from both sides, and we're going to look at that much later. And then lastly, the limit as x goes to infinity of f of x, or the limit as x goes to negative infinity of f of x, which is asking what happens as we let x get really big, or as we allow x get really big but negative, to the function f of x. So here's a picture of a graph. There's a hole in the graph, and there's nothing after the hole. This is a graph of f of x, and imagine if you were actually on the graph walking along f of x from left to right. Anytime you're at a specific x value, a, we can ask, what is f of a here? And so as we walk from left to right, you can see, walking along that orange line, we'll hit values like 1, and we'll dip down a little bit. We'll probably hit, 0.6, and then we start increasing. We hit 1 again, and eventually we're going to work our way up to 4 as we walk from left to right for our x values. So the question is, what does f of 4 want to be? But f of 4 isn't defined, and so we can't just say, well, what's f of 4? So the symbol, the limit as x approaches 4 from the left of f of x, asks, as you walk to x equals 4 from left to right, what is a natural choice for f of 4? And so take a second to think about what the natural choice is. Here, we can see that y equals 2 is a good choice, right? If you walk along that curve, where f of x wants to be when x is 4 is 2. And so what we say is the limit as x approaches 4 from the left of f of x is 2. Likewise, if we walk along f of x from the right-hand side, going back towards it, right, we can start to the right of 1 here, and we can move closer and closer to it. We can ask the same sort of question, which is, what is the limit as x approaches 1 from the right of f of x? Which again asks, as you walk towards 1, towards x equals 1, from the right-hand side, what is a natural choice for f of 1? And you can see that y equals negative 1 is a really good choice here. And so we would say the limit as x approaches 1 from the right of f of x is negative 1. On a number line, there's these symbols a minus and a plus. A minus looks like all of these numbers getting closer and closer to a from the left-hand side. And a plus looks like numbers getting closer and closer to a from the right-hand side. So when we're only taking one-sided limits, we're concerned with either the numbers on the left or the numbers on the right, but not both. And we're never concerned with a. We never ask ourselves, hey, what's happening at a? We're only asking ourselves what's happening near a, and only on one side. And it's totally possible that the limits on both sides don't agree. there's no reason to believe that the graph has to do the same thing on the left side of A as it does on the right side of A. And so here's a graph. There's a lot going on the graph. And what I want you to do is I want you to pause the video and I want you to think about these 6 limits. If pausing is not enough and you need to go back and review what the symbols mean, do that, come back here, pause it, and evaluate the answers. Now that you've paused, we're going to go ahead and fill these in. So the first of these 6 says the limit as x approaches -3 from the left of f of x is what? And if you look, that's talking about these numbers. And as we approach -3 in that direction, we're trying to go closer and closer to 1. And so the answer of that limit is 1. And now let's look at what happens as we approach -3 from the right, which is the second. As we approach -3 from the right, we're approaching what looks like -2. And so our limit is -2. Here we want to approach 1 from the left. And as we approach 1 from the left, it looks like our value is approaching 2. And as we're approaching 1 from the right, our value is approaching 1 for f of x. And lastly, as we approach 3 from the left or from the right, we're approaching the same y value. The y value that we're approaching is 3. Note that even though back at -3, right, back here, f of x does have a definition. F of -3 is 1. Here, at x equals 3, f of 3 is 2. And here, at 1, f of 3 is nothing. Even though sometimes f of a is defined or it's not defined, it doesn't affect our limits. We don't care. The limit never cares about what's actually happening at the value that we're heading towards, only what's happening nearby. So here, if we look on the right-hand side and we walk towards 2 from the right, the limit is -1. But what happens as we get closer and closer to 2 as we walk from left to right? Well, you can see what's happening is that the value f of x, or the y values, as we walk along this, we're getting higher and higher and higher. We're getting bigger and bigger and bigger. And the way we write that is that the limit as x approaches 2 from the left of f of x, well, that's positive infinity. And so what happens if we so that answers what happens as we get to a value, but the y value gets really, really big. But what happens if we let the x value get really, really big? Right? And so here, what we write is, we write the limit as x approaches positive infinity, or the limit as x approaches negative infinity, to represent what happens if we basically never stop walking. Right? If we walk along the graph, but we go forever. If f of x levels out, then we say the limit exists. If the graph never settles into a nice pattern that gets flatter and flatter as we go out, then the limit won't exist. And so here's a picture of a graph. The graph does something different on the right than it does on the left. If we look at the left-hand side, this limit symbol, the limit as x approaches negative infinity, that keeps getting more and more negative. And so we say the limit of f of x as x approaches negative infinity is equal to negative infinity, because as we walk to the left, it gets more and more negative without any bound. Over here on the right, the limit of f of x actually does exist and is in fact 1. And the reason it's 1 is because as we move further and further to the right, these little humps above and below 1 are leveling out, and the graph is conforming more and more to y equals 1. Sometimes what we want to know is whether or not the limit on the left and the limit on the right agree. The way we do this is by just asking what is the limit as x approaches a of f of x. We don't use a minus and we don't use a plus, we just ask as x approaches a. The limit as x approaches a of f of x exists if the limit as x approaches a on the left is L, and the limit as x approaches a on the right is L for f of x. And if it is, if they're the same value, then we say the limit as x approaches a of f of x is L. It's okay also for L not to be a number, right? And L could be 2, but L could also be positive infinity, or it could be negative infinity. And so here's 3 graphs, and we're asking ourselves, well, what are the limits as x approaches 2 for the 3 functions? So for the first function, if we do the limit as x approaches 2 from the left, we get 1, and as x approaches 2 from the right, we get 0. Since 1 and 0 don't agree, we say the limit as x goes to 2 of f of x does not exist, or DNE. In the middle one, the limit as x approaches 2 on the left is positive infinity. The limit as x approaches 2 on the right is also positive infinity. So we say that the limit as x approaches 2 of g of x is positive infinity. Lastly, on the right, the limit on the left, just like the middle one, of h of x as x approaches 2 from on the left, is positive infinity. But the limit on the right is negative 2. And since positive infinity and negative 2 don't agree, we can't say the limit makes sense. Right? So the limit as x approaches 2 does not exist. Now, it's really important. You need to know when you're being asked about the limit at a point, the limit at infinity, or the limits on the left or the right side of a point. Each one can have a totally different answer. And so you have to pay attention to the symbol being used at the bottom. If you don't know what the symbol is, you can't answer the question. So go back, review through the video, get used to the idea of there being 4 different questions we could ask, do the homework, and I'll see you in class.